In my home country of Australia, split systems are the major format for heat pump water heaters, and they are really in all of Asia and Europe. So I was a little bit surprised to find out when we launched our product here a couple of years ago that um, general knowledge of heat or split systems wasn't where we thought it was. So we're spending a lot of time in the last 18 months really introducing split systems to as many contractors and program managers as we can find, just to let them know that it's a really viable option for plumbers to be putting into homes, alongside the towers. The towers is a I think a historically strong format for this, but split systems are definitely a very viable option in some homes. And in
Have your
Australia,
presentation up, by the way.
sorry,
I got the presentation up.
yeah, I see that. And just for everyone's knowledge, and with split systems, my Australian colleagues and companies started doing heat pump water heaters about 8 years ago in Australia. And like here, we had a integrated tower and a split system. We just sort of let the market tell which way it was going to go. And that business at the moment in Australia is probably 85% splits and about 15% towers. So, I just want to educate everyone a little bit today about the split systems and how they compare. So maybe the next slide, please, Andrea. So today we're going to try and do this. We're going to talk a little bit about how heat pump water heaters actually work. So there's probably a lot of knowledge in the group. I'm not sure, but I'll take it back to basics just in case. Talk about some real world challenges that integrated towers have. Why split systems can solve some of these challenges and issues. Sorry about this background noise. Performance comparisons, UEF, and all the different comparisons, all the different ways of measuring performance. Splits fit homes from mansions to manufactured mobile homes, ADUs, small homes. And there is definitely a global trend why split systems are becoming a norm, and some practical benefits for your contractors and homeowners. So that's what we're going to try and do in the next half an hour or so. So next slide, please. So some key terms that you'll see in my presentation that we're happy to share later. Heat pump water heaters, that's what we're here to talk about. Integrated towers is where you have the heat pump sitting on top of the water tank. So it's all in one, the heat's right on top, the water tank is below. And that's a format that people are used to looking at with, the old-fashioned electric element heaters. It's all there in one unit. A split system, we put the tank indoors, the water tank's indoors, there's backup elements, and the outdoor unit, the remote heat pump, is ideally put outside in the fresh air. It can be on a platform outside, it can be on a wall outside, it can be on a balcony. It can be in big internal spaces like a garage if it's ventilated, but in an ideal world, the heat pump outside, and that works in all conditions as we get onto. There's kind of three refrigerants that are used in heat pumps around the world, three general ones. HFOs, which is hydrofluorolefin, which sounds a little bit like one of the players for Holland at the moment, and it's a mouthful. But it's a low pressure, zero flammable refrigerant, and we use that in systems, and it's where the split system's running the refrigerant through the wall. HFCs, everyone's heard about hydrofluorocarbons. They have a higher global warming potential, but that is a refrigerant that's used in most integrated towers now. So some of the integrated towers are really going to have to start working on changing their refrigerants to get under some of the new thresholds. Like in California, you've got to be under 750 next year. I'm not sure about DC. Some states are going even lower. And then the other general one is carbon dioxide, which is in some systems. And the split systems that use carbon dioxide put water through the wall. They don't put the refrigerant through the wall. And there's benefits and cons, pros and cons both ways. we find in very cold areas like DC, putting water through the wall with freezing pipes, etc., can be a little bit of a danger. So we kind of steer away from that. So next slide, please. Whoop. Yep. So there's an image of the integrated tower with the heat pump on top. So how do heat pumps work? They move heat from the atmosphere and they use the same heat to heat your hot water. Heat pump water heaters are not creating the energy, they are moving the energy. Something like the old-fashioned refrigerators and today's modern refrigerators do heat pump water heating in reverse. They're taking the heat out of your refrigerator, pushing it out into the atmosphere. We're taking the heat out of the atmosphere and pushing it into your heat pump to heat your water. So you're moving energy, you're not creating energy. And that's one of the reasons you can save. In a classic heat pump water heater, and this is a really important point, 1 unit of electricity, 1 unit of energy will deliver between 3.5 units to 5 units of heat. So it's a great multiplier of the energy use. In a normal, so everyone knows, in a normal old-fashioned gas or an electric element heater, for every dollar of energy you spend, you're getting about 92 cents, 93 cents worth of hot water energy out of it. So if you take that back to the 3.5 or to 5, that's why heat pump water heaters to run cost about 20% of the cost of gas or electric energy use. And that's a tower there. You see lots of them around the USA. That's the current format in lots of places, but we're going to offer something different. So next slide, please. This is really just another demonstration of what's going on inside the tank. You can see the cold water comes in, hot water will go out, hot air goes in, cold air goes in. That's what's happening. And the elements you see on the water tank, the electric heating elements, are in there as backups, but the refrigerant lines wrap around the tank on the inside, and that's what's heating the water as the primary source. The refrigerant in those lines is heating the water, but then you have some backup elements to give it a boost if you need to, for maybe particularly cold climate and cold times, or if you've got the football team arrives and you need to really be churning out some hot water, the elements will kick on to do that. And these are what we call hybrid systems. Yep, that's fine. So the challenges of towers. Heat pump water heaters require the energy from the atmosphere to work. So you've got to, in an ideal world, the minimum you want to have is on a tower 700 to 1,000 cubic feet. So that means that you've got to really be looking at, a big space like in a basement or a super ventilated closet, garages, but you've really got to be churning the air, because if you're not churning to fresh air all the time, the system is slowly but surely getting less and less efficient because you're churning the same air that you've churned before. They do push out cold air. So you have to be very careful. If that air is not being vented to the outside, it's going to cool down your space. So in a DC apartment, if you're spending money to heat your apartment, your heat pump tower can be stealing that heat to heat the water and then pushing cold air back out. So the ventilation on a tower is super important for it to be efficient, and it really does have to have access to a whole bunch, 700 to 1,000 cubic feet of fresh air, just to keep things going efficiently. Because the heat pump is sitting on top of your tower, of top of your tank, there is noise. There is noise, and it's about the same as a modern dishwasher. So it's not a lot of noise. Manufacturers have worked hard to keep the noise down. But if you've got an old element heater, you're used to not a lot of noise, and then when you get the new technology, it creates noise. So that can, depending on where it is, if it's near a bedroom or near a space that you're hearing it, that can be annoying. A tower produces up to 2 gallons of condensate a day. So you really may have to make sure that there's a condensation line going to the outside or going to a drain or something to make sure that that condensation that's coming from the atmosphere originally, that is created by the process, that has to be removed from the area. So that's one of the installation challenges for the plumbers. On a practical point of view, these towers are typically about 275 to 310 pounds. So, and they are top heavy. So you're maneuvering them around. It takes a lot, a couple of strong guys and strong dip to do it. And if you're going up and down stairs, being top heavy, it's a challenge. And you can't lie a tower down in transport. You'll see when we get in the split systems, in transport, you can put our water tank horizontal, which again is easier for the plumbers, their vans, etc. Okay, next one, please. This is heat pump water heaters, and this is a few of the ones on the market at the moment. Sanco on the left is a carbon dioxide one. It's a great unit. It's a Rolls-Royce of a unit. It runs water through the wall, and it has good UEF, which is the unitary energy factor. And it has I think, great application, particularly in central basements where whole apartment buildings are being serviced from big tanks, because they can have a string of their tanks in a basement, and that will work pretty well. Next was we have a system, and we run the refrigerant through the wall. We have super good first hour ratings, great UEF form factor. You'll see we're highest in the split systems, which means the higher the UEF means the more or the less energy the system is using to heat the hot water. So it's going to be the cheapest to run. It's got the highest UEF. A.O. Smith is like Sanco. They run water through the wall. And then there's the smart solar guys out there who are running it of solar as a split system. Split systems are in the UK, basically in the rest of the world, split systems are the #1 format. The USA is playing catch a little bit here, in my view. The split systems are also easier to service because they're not jammed in and crammed in spaces. Condenser sitting on a stand somewhere by itself, so it's very easy to work on. And the water tank inside the home is basically a water tank. So any servicing is going to be happening on the heat pump outside. Okay, next slide. Splits. This is the fundamental difference between the splits in the market, which I've mentioned a little bit about. One is putting refrigerant through the wall, one is putting water through the wall. So our system puts refrigerant through the line. We use a low greenhouse gas refrigerant line. It's 584, I think. And we have micro channels that wrap around the tank inside. They're flat alloy, so the surface area is very good on the tank. And because we have flat horizontal coils around the tank inside, we actually use less refrigerant than some other systems will do, which once again makes us more efficient. We are a hybrid, so we do have backup elements in there, and they will come on if we get down to extreme, like as you see in the document here. Once we go below 5 degrees Fahrenheit, the elements will kick on to heat the hot water to protect the heat pump. Once the temperature comes back up above 5, the heat pump will start to work again and the elements will go off. They work in tandem. The unit is very intelligent, and so we are And I think 5 degrees, even though my daughter just spent 3 years in DC, now you have temperatures that go below that, but there's not, I don't know how many days a year it is. And a heat pump water heater is for everyone to know. Typically, a heat pump water heater reheat your water for, and only run about 5 or 6 hours a day on a typical family situation. So it's not like it's running 24/7. And refrigerant through the wall typically more efficient than the carbon dioxide systems, which was on the chart before. The wall through the wall, fellas, they running with CO2. It's got a zero global warming potential, so that is fantastic. They do have the water through the wall, which is a danger, as I said, and they're lower in their efficiency. And I think one of the challenges for everyone is that because they're using carbon dioxide, the valves and the components have to be very strong and to keep it sort of, in a contractor term, which means that typically the CO2 systems are twice the price of refrigerant systems like ours. And it's all in the engineering that it creates that extra cost. Right, next slide, please. We've covered this a little bit already. Here you have a tower, an integrated tower on the left-hand side, and it's going to be stealing the air to heat the water. Then it's going to be pushing cold air out. So you just want to be very mindful of that, know where it's going. Our one on the right isn't doing any of those things because the heat pump is outside. So you get no room conditioning, as we call it, no interior noise, no condensation management, no venting needed, no louver doors, blah, blah. It's easier to service. I've been through a few of these points already. They're about the same, I think, in our experience day with our contractors who are doing both. The time to install the units is about the same. They both have separate challenges, split systems. You've really got 2 different spots to install, and you've got to run the refrigerant line through. But with the towers, you've got to do all the venting and the condensation. So there's different challenges, and it seems like the actual time, once people get used to the system, it's about the same. In our system, no, if you could just go back one more, the distance in our system is 33 feet. So at the moment, you can't have your heat pump more than 33 feet away from the tower for the refrigerant lines to operate effectively and at their best. With the CO2 ones, you can be 65 feet away. And that's one of the reasons why they've been used quite a lot in big commercial basements with the heat pumps outside somewhere in an alleyway or whatever. They can go that 65 feet. Okay, next slide, please. This is a shame Carl's not here. He loves his slide. It was his invention. We believe this, and only time will tell, that the CFL of light bulbs and is what we regard the old Techno unitary towers. We're at that stage with the unitary tower, but as the market finally gets to what we call our LED moment, split systems are really going to come to the fore. And off a general comment I would make, if there's anything under new construction, there's absolutely no reason why you wouldn't go straight to split systems right now today and install split systems when you're building new construction. When we're retrofitting into old construction, sometimes the tower may be the best solution and sometimes the split system. And what our message is to all of the market at the moment, we just want the contractors to be aware of both ways of doing it so that the homeowner, if they're retrofitting into an already built home or apartment, ADU or whatever, they get the best system for that environment today. Okay, next one. We're thrashed one, I think. You know, you got to worry about the space, you got to worry about the noise, you got to worry about the venting, the room conditioning, and condensation. So, next one. This is a good slide for everyone to wrap their heads around on the energy use. As you see here in red, on a classic electric element heater, on a national average, they're using about 3,500 kWh a year. And depending on your price of your electricity, you can work that out. A heat pump split system like ours is using 769 in a 240 volt, 681 in 120 volt. That's the big chunk of change, 5 times the energy usage. So basically, you take the cost of running your hot water from basically a kitchen table budget item to one that you don't have to think about anymore, because that's costing probably 10 to 15 bucks a month to run, right? So that's the big deal right there between the old tech and the new tech. Okay, next one. That's a summation of that, what we just talked about using Carl. Looks like Carl got your DC cost per kilowatt, and that's the savings over 10 years, the annual savings against gas and against electric. So these details will be in the presentation that we'll share afterwards. So, you know, it shows that it's the whole thing's substantial, right? It's a big deal towards, you know, helping climate change and helping people's pocket along the way. Okay, next. Um, this is once again, it's kind of split systems against tower on performance. And this is the UEF, the seasonal coefficient of performance, which is a term that's used a lot more in other markets. It's catching on here for sure. But the coefficient of performance is that multiplier that if you've got a coefficient of 5, it means it's 5 times more efficient than an element unit. And you can just see in the orange table at the bottom, which is the coefficient of performance, our splits is coming in just under 5.5, and you know the old systems are 1. So that we don't need to get into that detail because I think I've been banging on it about the performance. Next one. Ching, ching. And this is the one of the big differences between towers and the splits. It's the mechanics right there, right? In a tower, you use a small 6 to 8 inch fan on top of the water heater. We're using in split systems 13 to 18 inch fan. The split system, the evaporator coil has 4 to 6 feet. The tower has 1 to 1.5 feet. So just the physical power of a split system is one of the fundamental reasons why it's more efficient, and it's working so much more gently. And in my experience in Australia, etc., the split system heat pump water heater just lasts a lot longer because it's just not thrashing along like the smallest fan and the smaller evaporation coil is. So the physics is important. And so everyone knows, how do you service this heat pump outside? About once every 6 months, you just hose it off. That's it. Okay. Talked about the installation benefits. It's just a lot easier to push, you know, you can carry these units in on a dolly or carry them in if you're strong enough just by yourself. You can transport it lying it down horizontally. And both of it, we think it's 4 to 5 hours once people understand what they're doing to install these units. Okay, next one. This will give you an idea of if you have in a small 860-foot 2-bedroom apartment, like an ADU or a mobile home or an apartment, that gives you, if your unitary tower is sitting in the corner there in a closet, that gives you a throw of how far the noise goes. and how far cold air will go if you're not venting it properly. So that's why we talk about the conditioning air. So you've got to be really mindful of that at the install stage to make sure that's not happening. And we have, I don't think it, I don't know about DC. I'm not sure. I didn't see a lot when I was visiting my daughter. I don't think you have mobile homes, but we have an 18 and a half inch diameter slimline tank that actually fits in mobile home closets, but it also fits in the narrow closets you find in garden apartments, in apartments sometimes. So, or some of them are under stairwells, you know, those small spaces. So our slimline tank is proving very popular for that reason. And as our contractor say, and it's even got handles to make it easier for them to carry them in and place in position. And next slide. This is what we talked about earlier, you know, apartments. There's no reason why, and if you travel into Europe or Australia, you'll see lots of these heat pumps, the outside of buildings, on brackets outside. You see them on the balconies of buildings, or you can have them, I've said, as central systems in the basement of a big apartment building. You can have a heat pump split system with the units outside. You know, I think that's enough. Next slide, please. Once again, for ADUs, you know, I'm talking to, oh, sorry, here comes Mr. Noisy back again. I'm talking to a tiny home manufacturer who is really interested in this because, like any of these tiny spaces, if you can put more things outside, then the more space got inside, right? So, and it's even to put the water tank outside while you're building a tiny home, to put a small closet on the outside is cheaper than using up conditioned space on the inside, right? So, next slide. Blah, 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 blah. Yeah, investment versus efficiency and comfort. There we go. Next slide. I think that's us. Shameless plug, as Carl said. We've got different models, and just so you know, as you can see there, we have just 50-gallon version and 80-gallon version. All of our units ship with a mixing valve. And because of that, we say our units got a superpower because you can actually heat our units up to 140, 150 degrees. We send it from the factory at, I think, 125, but you can, by turning up the heat to 150 or 150, putting it through the mixing valve, it means that basically your 50-gallon tank has become a 68 or 70-gallon tank because you're adding cold water to the hot water on the way out. So you're actually really increasing the first hour rating. And one of the reasons why we said, well, we don't actually need a 65-gallon tank. We can just do that by superheating the water. And if you superheat the 80-gallon tank, you've got like 100, 105 gallons of first hour. So that's for everyone to know. And we ship, that's all included in our unit is the mixing valve. Next slide. Blah, blah, blah. The future water heating is here. And just so we know, because I'm not quite used to Carl's deck here, we have everything comes with a control panel. We've got an app so you can change the temperature, etc., through the app or the control panel. We have vacation mode. We have the eco port for demand response. You can superheat the tank for, you know, if one of your utilities wants to preload the energy up. So we've got all that tech going, and you know, I joke with all the qualifications now, our tank's got more stickers than a Formula One race car. So that's it. I guess I'll open it up to any questions. I've got about 7 or 8 minutes, or I've got to get going. So, and I'm sorry again about the background noise, folks.
You could not hear the background noise, and at least I couldn't. That was a great presentation. Thank you so much, Rod. Any questions for Rod? And Rod, is is this a shareable presentation?
Yeah, and it's got our contacts, I think, at the back end of it, Carl said. So yeah, I'd more than happy for you to share that, and you can give everyone our contact details if they're not there. I think they are.
Yeah, I'll make sure to send everybody the presentation after this meeting. And any questions for Rod? No questions? Okay, well, if there are any questions, I will be sending over this presentation, and there is an information email at the bottom if you wanted to email it. Rachel Leah, did you have a question? Distribution of this product in the DC area. I don't know where the question is. Oh, Rachel, there you go.
Yeah, the split system, who's carrying it, who's distributing it, and where do we get training on it?
I can answer that question for you. My name's Greg. I'm with Eco Logistics. We are the supplier for the splits and the towers available through Eco Logistics or Ecological for the Maryland, DC, and Virginia area. We can deliver anywhere in the area, and our guys are partnering with Rod and Carl to provide the training. We've trained 2 contractors in Maryland here in the past month that we're supplying for various programs that they participate in.
Thank you.
Sure. If you want, I can give you my direct phone number. You can call me. I can give you more specific details. I posted that in the chat, but it's 443-769-5961.
Then our experience, guys, is that we really love to train contractors on the first couple of installs, because if we do that and they just learn a few different nuances about our system, then our phone doesn't ring. So we like to invest upfront in the training as much as we possibly can, because we don't like callbacks. Contractors don't like callbacks. Program managers don't want callbacks. So that's the best way to avoid that.
Great. Thank you so much, everybody, for coming. I'll be sending over this presentation, and we will see you next month for a monthly meeting. Thank you so much, Ecological, and I hope everybody has a great rest of your week. Bye, everyone.
Thanks,
Thank
Greg.
you, Rod. Thank you, everyone.
Thanks, Rod. Nicely done.